Okay, this is numbers 26 through 30 for the practice test, chapters 9 through 10. For 26, we have r is equal to 10 sine theta. You've been asked to put this into rectangular form. So some formulas that you'd like to recall at that point was the equivalent of r squared in rectangular form is x squared plus y squared. We also had formulas like this. X is equal to r cosine theta, and we also had one for y, which is r sine theta. These are the sort of things that will take you, the formulas that will take you from polar information to rectangular information. So if I can replace r squared with x squared plus y squared, I want to create an r squared here, which I can do by simply multiplying the left side by r. Therefore, I have to multiply this side by r as well. That leaves you with r squared is equal to 10r sine of theta. This right here can be replaced with its rectangular equivalent, which is y. Drop down the 10, and the r squared can be replaced with its rectangular equivalent, which is x squared plus y squared. Okay, and you can leave it like that. You don't need to bring everything to one side or complete the square. You can keep it at that level. Okay, and number 27, you've also been asked to come up with the rectangular equation, only now you're into parametric equations, which you can tell by the parameter t. You have a parameter t here instead of a theta. That's the parametric equation for x. The parametric equation for y is 2 cosine t. They say that these two functions are defined over the intervals 0 to 2 pi. In other words, if you were graphing it, you would accept anything from 0 to 2 pi in the graph. However, they've only asked you to come up with the rectangular equation. So in these parametric equations, you're going to want to isolate, that have trig words in them, you're going to want to isolate the trig phrase. That would give you sine of t is x over 2. And since we're going to be plugging this into the Pythagorean identity, which has sine squared in it, you want to make this side say sine squared. So square this side as well as this side, so you'll actually be able to plug it into the Pythagorean theorem, Pythagorean identity. So you have x squared over 4 is equivalent to sine squared. And then likewise do the same thing for your expression for y. So you're going to want to divide both sides by 2. And that would leave you with y over 2 is equal to cosine of t. Again, we're going to be plugging this expression as well as what we get here into the Pythagorean identity. And these words in that identity are squared. So you want to square the right side and the left side. That'll leave you with y squared over 4 is equal to cosine squared. Then you need to grab the Pythagorean identity that contains these two words. Sorry, that needs a square, which is sine squared plus cosine squared is equal to 1. And then you can replace this sine squared with its rectangular equivalent, which is x squared over 4. And you can replace cosine squared with its rectangular equivalent, which is y squared over 4. Now, in the case where the coefficients of both x squared and y squared are the same, coefficient here is 1/4, same thing here, you're going to want to express this equation in circle form, because this is a circle when the coefficients are equal. So multiply by 4, and that would give you this times this, that would cancel with that, giving you x squared. Likewise, when you multiply it by this, the 4's would cancel, leaving you with y squared. And then finally, when you come over to the other side, distributing the 4, you would get this. And that will be your equation for number 26. Okay, and that's a circle. Center at 0, 0, radius 2. Okay, number 28. Problem 28. Pretty much the same thing. All you're going to be doing is using a different Pythagorean identity towards the end of the problem. The Pythagorean identity that has tan and secant in it. So you need to have those Pythagorean, all 3 identities memorized. Okay, and they want you to keep, this is mostly for graphing purposes, then you would keep your graph from negative pi to pi. But again, all you're doing is coming up with a rectangular equation as you did in number 27. So isolate the trig phrase by getting rid of that coefficient of 4. That leaves you with x over 4 is equal to tan t. In the Pythagorean identities, all the trig phrases are squared. So let's square this as well as this, and you get x squared over 16. Likewise, for the secant equation, divide both sides by 3 so that you're isolating the trig phrase. Then get it in its squared form, since you will be plugging into Pythagorean identity with these expressions. This will give you y squared over 9 is equal to secant squared. Then you want to take out the Pythagorean identity that has the words tan squared and secant squared, and that would be this one. So you need to have those memorized. 1 plus tan squared, and these are from chapter 6 and 7. We used these Pythagorean identities. Actually, we used them in every chapter. And there was 3 of them. This is one of them. You'll also find it on your formula sheet. Okay, so plugging into this, tan squared was x squared over 16. Secant squared is y squared over 9. And you're going to want to, now see, these coefficients are different. So this is either an ellipse or a hyperbola. And you want to wait until you get this number 1 by itself in order to make that decision. So you're going to need to move this expression, this term right here, x squared, positive x squared over 16 to the other side, at which point it becomes negative x squared over 16, which at that point you can see what the shape is, which is a hyperbola, because when one of the squared terms is positive yet the other one is negative, that would be the hyperbola. So I'm going to continue this on the next page. For this particular problem, I believe all they wanted you to do was to come up with the equation. So your final answer is y squared over 9 minus x squared over 16 is equal to 1. Same as what I had on the last page. And this is just the completion of number 28. Okay, going on to number 29. Now they want you to describe the curve. So this is when you're going to specifically want to pay attention to the restrictions on t. Now you could put these into the calculator in their parametric form, but you can also do what we've been doing in 26, 27, and 28, which is to come up with the rectangular equivalent of the equations. Okay, so we're going to make sure that our graph stays within 0 to pi range when we do go to graph it. And if you want to use the technique similar to what, there's an 8 that goes here. That the technique similar to what I did in 26, 27, and 28. Parametric equations that have trig phrases as part of them. You want to isolate that trig phrase by dividing off the coefficient. Do the same thing on both sides. Then you have cosine of t is equal to x over 8. We're going to be plugging this into the Pythagorean identity, which everything is squared in that in those Pythagorean identities. So let's get this in the squared form. Square this side, square this side. And you have x squared over 64 is equal to cosine squared. Then for the y equation, again, isolate this trig phrase by dividing both sides by 8. Then you'll have y over 8 is equal to sine of t, and so that it fits into the Pythagorean identity, you're going to want to square both sides to get it in its squared form, and then you'll have sine squared t is equal to y squared over 64. Taking out the appropriate Pythagorean identity, you have cosine squared plus sine squared, or you can write it sine squared plus cosine squared is equal to 1. And plug in the equivalent for cosine squared and sine squared according to this problem. This is equivalent to x squared over 64, and this is equivalent to y squared over 64. Now, as I mentioned in a previous problem, when the coefficients of x squared and y squared are both positive and both equal, they are 1 over 64, 1 over 64, that means it's a circle. And so in that case, you're going to want to get rid of the fractions so that you can express the true radius over here. So you're going to multiply by 64 to wipe out these fractions. This times this would cancel, leaving you with x squared. 64 times this would also cancel, leaving you with y squared. And 64 times 1 would be 64. So this is the form of a circle equation. This number over here stands for r squared. Therefore, r would be the square root of 64. So you're looking at a circle with radius 8. So that would mean 8 this way, 8 to the left, 8 up, 8 down. However, you're supposed to stay restricted between 0 and pi. It's a little equal sign there. 0 and pi, so that means the graph that you're about to graph, instead of doing the entire circle going from 0 to 2 pi, you're only going to keep it in these two regions, 0 to pi. So this is 0, this is pi, and you're still going to go with the radius of 8. So let's say this is 8, this is 8, this is 8. But since you're not allowed to move out of the 0 to pi range interval, that's why you're going to keep only the top part of the circle. So number 29 would be choice C, the upper portion of a circle. Okay, last problem. Number 30. In number 30, you have x is equal to 5 tan of t. So x is represented by this parametric equation, and y is represented by 4 secant t. When you go to graph at the end, you can graph anywhere between 0 and 2 pi, inclusive of those endpoints. Okay, so you'll be able to graph the top, anything in the top portion or bottom portion. You can use all 4 quadrants because you're trying to relate this to the x and the y system. If you're thinking trig, then 0 to 2 pi is anywhere from here to here. If you're thinking x's and y's, that means that you are allowed to graph in quad 1, 2, 3, and 4. So you're relating these thetas, and the polar values and the thetas that you have to the xy system. Okay, so now if you want to get a rectangular version of this equation as we have in the previous problems, you're going to isolate the trig expression, leaving you with tan t is equal to x over 5. We'll be plugging this into a Pythagorean identity where everything's squared. So you're going to square the right as well as the left. That gives you x squared over 25 is equal to tan squared. Okay, then for this y expression, again, isolate the trig phrase. You're left with y over 4, very similar. Almost exactly like what I did previous problems, only you're going to the extent where you're graphing this time. Let's square this so we can use it in the Pythagorean identities. You get y squared over 16 is equal to secant squared. Then you're going to choose the Pythagorean identity that involves these two trig expressions, and that would be 1 plus tan squared is equal to secant squared. And if you substitute the expressions that are equivalent to tan squared and secant squared, you have 1 plus x squared over 25 is equal to y squared over 16. Now in this case, the coefficients are not the same. Coefficients of x squared is 1 over 25, while the coefficient of y squared is 1 over 16. So in this case, what you want to do is leave the 1 rather than get rid of it as you would in a circle, but bring the x and y expression to the same side. In doing so, you would move this over to the right side and it would become negative. Okay, and as soon as you have one negative and one positive expression in your x's and y's, that becomes a hyperbola. This is no longer here. So this equation can be written as x squared over 25 minus y squared over 16. And if you recall how to graph these, just real simple. This is, you have to take the square root. This is called your a value. Square root of this is how far you're going to move in either direction along the x-axis, because this a value is found under the x squared expression. So it speaks to you as far as how far you're going to move on the x-axis, this way and to the left. The expression found underneath the y is called the b squared value. We call that value the denominator of the negative expression. So therefore b is equal to the square root of this, which is 4. And this value being found under y squared refers to how high and how low you are going to go in the y direction. So let's say this is 4, and let's say that this is negative 4. Okay, now once you have moved using these values under x and y squared, you're going to construct a rectangular auxiliary box, which is going to kind of guide the width of your hyperbola. Okay, so there's a little rectangle. Draw the diagonals that go through opposite vertices. And then you have to decide whether you should open one up and one down, or should you open them sideways. And the way that the openings go is always with respect to the positive expression. This one's considered negative because of the minus. So if the positive expression involves x, you will open your hyperbolic wings in an x-like direction. In other words, horizontally. Okay, so you're going to come right here at the edge of the box. Stay within those asymptotes. So there's one of your hyperbolic wings, and the other one will be inside the asymptotes over on the left. Okay, that completes the review for chapters 9 through 10, numbers 26 through